So I know that double replacement problems can look intimidating, but in some respects they're a little bit easier than the single replacement reactions because you don't have to worry about diatomic atoms. The steps are very similar to predicting the products of a single replacement. The first thing you do is identify your positive and negative ions, and then you determine what ions are going to trade places. So it's easiest to just say the two positive ions will always trade places with each other. When I rewrite this, I'm going to rewrite the hydrogen with the hydroxide ion, and I'm going to write the potassium with the sulfate ion. At this point, you want to look at each of your compounds and make sure that you have neutral compounds. Hydrogen is a +1. Hydroxide is a -1. So we have a neutral compound here. Potassium is a +1. Sulfate is a -2. To make that a neutral compound, I need to crisscross my charges, and I have K2SO4. For my second problem, we'll do the same thing. Let's identify our positive and our negative ions. Iron is positive, sulfur is negative, hydrogen is positive, and chlorine is negative. Now this problem is a little bit different because iron is a transition metal. So we can trade places with the hydrogen, but when I have my product of FeCl, and I'm trying to create a neutral compound, I know that chlorine's a -1, but I don't know what the charge on the iron is. So let's go back to our original iron sulfide and try to figure out the charge on the iron atom. We know that sulfur has a -2 charge, and there's only one of them. So in order to balance the -2 charge on sulfur, this particular iron atom has to have a charge of +2. That +2 charge will carry over to my product side. So I'm going to write my iron with a +2 charge. The hydrogen is going to partner up with the sulfur. Hydrogen has a +1 charge. Sulfur has a -2 charge. Let's go ahead and crisscross our charges so that we have a neutral compound. When I cross the charges on iron 2 chloride, I end up with FeCl2. And when I cross the charges on the hydrogen and sulfur, I have H2S. The one thing you need to be really careful with on the double replacement reactions is 1, you always need to have the positive ion first, and 2, you need to be careful that you don't accidentally carry over the subscripts, right? Every time we include subscripts, it's because we're trying to make a neutral compound. Unless we're talking about a polyatomic ion, in which case you cannot separate that SO4. So that 4 is going to stay with the SO4 because it's part of the polyatomic. But the 2 in the K2, the 2 is there because it came down from the charge on the sulfate ion and it needed to make a neutral compound.